Welcome. In today's lesson, we want to talk about logarithm. And we know that logarithm is the reverse of indices. So a log of a number to a certain base is the power to which the base must be raised to obtain that number. A log of a number to a certain base is the power to which the base must be raised to obtain that number. Proof. All what I'm trying to say is that if we have log n base a, all should be equals to b. A log of a number n to a certain base a is the power to which this base must be raised to obtain the number. So what I'm trying to say that this one is coming back n equals a to power b. And we have the laws of logarithm, laws of logarithm, laws of logarithm, laws of logarithm. We have the law one, the addition law. Addition law. The addition law of logarithm says that whenever we are adding in logarithm and the two bases are the same, we take one of the base and multiply the logs. Again, whenever we are adding in logarithm and the two bases are the same, we take one of the base and multiply the logs. So all what I'm trying to say is that if we have log a plus log b, the two bases are the same. Whenever you're not giving a base here, we always have base 10. It's always base 10. All right, let's go. So whenever we are adding, the two bases are the same, we take one of it and multiply the logs. So what do we have? We have log a times b, which is, in a nutshell, ab. So that's it. Number two, the log 2. We have the subtraction law. Subtraction law. Let me write it. Subtraction law. Subtraction law. The subtraction law states that whenever we are subtracting in logarithm and the two bases are the same, we take one of the base and divide the log. Whenever we are subtracting and the two bases are the same, we take one of the base and divide the log. Proof. If we have log a minus log b, the law states that when we are subtracting, if the two bases are the same, we take one of the base and divide the logs. So here becomes log a divided by log b. And that's it. We have the next one, the power law. The power law. The power law. The power law states that when the log is raised to a power, the power is used to multiply the log itself. The power law states that whenever the log is raised to a power, the power is used to multiply the log itself. All right, let's go. If we have log a to power b, the log is raised to a power, the power is used to multiply the log itself. So what do we have here? This equals b multiplied by log what? Log a. All right, the next one. We have the reciprocal law. The reciprocal law. The reciprocal law. What does the reciprocal law state? The reciprocal law states that when the log is in the reciprocal form, the log and the base interchange their position. Or you can call it the fractional law. When the log appears as a fraction, the log and the base interchange their position. So what am I saying? In a nutshell, if we have log a base b, this equals 1 all over log b base a. If we have the reciprocal, if we have log b base a equals log a base b. if we have this equals this. All right. The next law we have is a log to its own base. A log to its own base law. A log to its own base law. A log to its own base law state that whenever the log and the base are the same, the result is 1. So what I'm trying to say that proof, if we have log a to base a, the result is 1. Whenever the log and the base are the same, the result is what? 1. All right, that is number 6. Okay, let's take some few examples of it. All right, we have this nice looking question on logarithm. We are asked to evaluate log 8 base 2 minus log 81 base half divided by log 1 over 64 base 4. How do we solve this? Let's go. Now from here we know that 2 to power 3 is 8. So here we can say 2 log 2 to power 3 base 2 minus 81 equals 3 to power 4. So we can say here is log 3 to power 4 base 1 over 2. All right. So from here, what do we do from here? Okay, 1 over 3. 1 over 3. Here is 1 over 3 from the question. 1 over 3. 1 over 3. All right, from here, what do we do? Divided by, here becomes log. We know that 64 is same thing as saying 4 to power 3. So from here, we are going to say 1 all over 4 raised to power 3 base 4. Okay, let's go. From the power law, we say that when the log is raised to a power, the power is used to multiply the log itself. So from here, we can say this is 3 log 2 base 2 minus, the 4 will go over the other side, 4 log 3. Now from here, positive index from indices, when we have a positive index, it equals the reciprocal of the negative what? Index. So from here, we know that here becomes 3 raised to power minus 1 divided by log positive. Here we'll take the negative index, it becomes 4 raised to power minus 3 base 4. Let's go. From here we have this equals 3 log 2 base 2 minus 4 times. Now from here, from the base power law, from the base power law, from the base power law, we say that when the log or when the base here is raised to a power, if we have log b base n, when the log here, the base here is raised to a power, the reciprocal is required. When the base here is raised to a power, the reciprocal is required. So here becomes 1 all over n log a base b. So here becomes, so we have 4 times 1 over 1 minus 1 over 1 log 3 base 3. All right, let's go. Divided by power law minus 3 log 4 base 4. So here, we say that whenever the log and the base are the same, the result is 1. Minus, here becomes minus, minus is plus. So we have here plus 4. When the log and the base are the same, the result is 1. So all over minus 3. When the log and the base are the same, the result is 1. So 3 times 1, 3. 3 plus 4, this is 7. All over minus 3 times 1, minus 3. So therefore, our answer becomes minus 7 over 3. Okay, we asked to evaluate this. Log 81 base x equals 4, log 27 base x equals 3, log the square root of 125 base 5. Now let's start from the other one. We have log 81 base x equals 3. Now let's obey the law of logarithm. Okay, equals 4. Let's obey the law of logarithm. When the log, a log of a certain number, what's the power to which the base must be raised to obtain that number? A log of a certain number to a certain base is the power to which the base must be raised to obtain that number. So this one comes back and this one raised to the power of this one from our logarithm. So we have 81 equals x to power 4. 3 to power 4 is what? 81. So we say 3 power 4 equals x power 4. From indices, equal powers, and x equals what? 3. All right, let's solve the next one. Number 3, we have log 27 base x equals 3. Now, this one raised to the power of this one, and this one comes back. This becomes 27 equals x cubed. 27 is what? 3 to power 3. So we have 3 to power 3 equals x to power 3. Equal powers, they will cancel, and x equals what? 3. The last one, which is the number 4, we have log square root of 125. Square root of 125 base 5. So from here, this becomes log. The whole of this thing here is 1 over 2. This is same thing as saying 1 over 2. So what do we do from here? We say this is 125 raised to the power of 1 over 2 base 5. Now from here, we can say that this is log 125 is 5 to power 3 gives you 125. So from here, we can say this is 5 to power 3 times 1 over 2 base 5. So here becomes log. Here becomes log. From the laws of indices, different factors in bracket reach a certain power. The two powers are multiplied for final result. So 3 times 1 over 2 give us 3 over 2 raised to the base 5. Laws of log with the power law. When the log is raised to the power is used to multiply the log itself. So here becomes 3 over 2 times log 5 base 5. But we know that when the log and the base are the same, the result is what? 1. So here becomes equals 1. And we have 3 over 2 times 1, which is 3 over 2. And this is the right answer. Thank you so much. Kindly subscribe, like, and comment. Bye-bye.